So to define regression model, we must use a linear model as follows. So write reg equals to linear model dot linear regression. This model, this command define linear regression model for our multivariable regression, for our multivariable data set. And to fit our train data to this model, we need to define reg.fit xtrain and ytrain. These commands feeds training data into regression model, and after it, this code calculate coefficients for our two inputs, one coefficient for x1 and one coefficient for x2. Then we must test our model. So define some variable as follows. So I define ypred to predict function of this model in the test data. So write reg.predict and here write xtest. Now we can see the coefficient, we can see the accuracy of model by using mean squared error and R squared. So define coef as follows, reg.coef and R2 equals to R2 score of y test and ypred. Then we define mean squared error as follows. So here write this, copy paste, and here after all of this code we can print them and see them in the output. So here write coef R2 and MSE. Now we are ready to see our output. So build your code and wait to see the output. I close this. Alright, two coefficients has been created for our model. This coefficient is for x1 and this coefficient is for x2, and the accuracy of model is 99.9%, and it is very good accuracy. We have a near zero mean squared error and everything is good, and we can visualize this data by using pyplot commands. So I want to define some pretty style for my plot. So use this library, and then we need to scatter plot ypred and ytest, and we can define some color for it. Color equals to, for example, blue, and you can add a title for it, for example plt.title, predicted data, versus real data. And you can define y label, x label, and some legends for your plot, but for time efficiency I ignore them and simply write plt.show. After it, we must define a 3D object for our output. similar to previous codes, I define fig2 and use plt.figure for it, and then we must define ax2 object for defining axis 3D that depend to fig2, and now we can scatter plot this data as follows. So ax2.scatter, and here write xtest, and here we need to select our parameters, so write length max temperature, and here we must define land mean temperature, so I copy and paste this code, land mean temperature. Then we must use a y-test for our plot, and here define some color for it. I define red color for it, and copy and paste this code for y prediction. So right here and use ypred, and here use green color, and finally use plt dot show. All right, everything I think okay, and we are ready to build for last time to see our output. I close this. All right, as you can see, this figure plots our predicted data and real data against them. As you can see, because we have a good error, we are near this line that split this square, and this line has a 45-degree slope. So when we have a good accuracy, our data are near to this line. After it, I close it. Alright, our 3D plot of real data and predicted data has been created, and you can see this data as follows. Because we have a good accuracy, the data plot on each other, and you can see them that plotted together. So in this lecture we learn how to use a multivariable regression model to estimate global temperature of Earth, and we use a simple data set for it, and you can use another data set to use for your regression model. So stay tuned to the next lecture, and thanks for watching.